Hello, welcome everyone. So I'm going to present this topic that is developers love GitOps. I know this name itself looks very fancy, but the tool is very much efficient and important one. And that makes the developers' lives very easily. So myself, Rahul Kumar Singh, I have been working as a senior DevOps engineer in Capgemini, Poland. So along with me in the right-hand side, you can see my colleague Yaroslav Zerwinski. He couldn't show up due to some medical emergencies today, so this conference is gonna led by me. Now, let's discuss what's the agenda we have it for this conference. The first, we will discuss the traditional way of CI/CD. So here we will discuss the common workflow we would have in CI/CD pipelines and how does it look like. As of now, this is the common workflow which is being currently used by the many industries. After that, we will discuss the why developers love GitOps and why we need it. Why we need to discuss the GitOps tool here for the developers. So before I answer these questions, I will tell you that what is GitOps and why we were discussing it here. And after that, we will discuss the CI/CD with the GitOps approach. As we have already discussed that in our first slide, that how the traditional way of CI/CD workflow would look like. And in this slide, we will discuss about the GitOps approach with the CI/CD pipeline, or we can say that the CI/CD workflow. After that, we will discuss the use case for the GitOps. Now we know what is this tool and how it is being beneficial and work with the CI/CD workflow. Now we need to understand that to whom it would be beneficial, either for the developers or for the platform engineers or for the Kubernetes administrator. And after that, we will discuss that the limitation of GitOps. As we know that in software development lifecycle, whenever a new tool is being developed or introduced, it doesn't have the perfect solution for all of our issues or problems. There would be certain limitations as well. So in this slide, we will discuss about the limitations of GitOps as well. And after that, GitOps supported deployment strategies. So whenever we are discussing about CI/CD workflow, definitely we need to discuss about the deployment strategies as well. So here we will discuss what kind of deployment strategies is being supported by the GitOps. And after that, we will discuss the most major and we can say that the popular GitOps agent, that is Flux, Weave GitOps, or we can say that an Argo CD. And after all this discussion, we have prepared a demo as well to showcase with Flux and Weave GitOps. Now, let's proceed to our first slide, that is traditional way of CI/CD. So as you can see here, I have prepared a workflow not to make very complex and discuss more time on CI/CD workflow. So as you can see here, when a developer made a commit, and it will push to the GitHub as a source code repository, and automatically a build would trigger. And this has been integrated with Webhook. And the Jenkins is working as a CI server. And what Jenkins does, it artifact pushes to the container registry, and the new release has been deployed with the help of CD tool to any on-premise, we can say that environment, or any cloud environment. This is how the traditional way of CI/CD workflow would look like, or we can say that as of now, nowadays, this is how the traditional way of CI/CD pipeline would be mostly being used. In the next, we will discuss why developers love GitOps. So before I answer this question, let me first tell you that what is GitOps. So GitOps is not something any tool. GitOps is a process that use Git as a source of truth and which help developers to deploy them and manage the application and infrastructure code repositories. So just like as DevOps is not something in a tool. There were tools, those comes under DevOps. The same way we have GitOps. So GitOps is a process. The tools, those come under the GitOps, those are called GitOps agent or GitOps tools, we can say that. The first point we would have, that is simplicity and familiarity. As we all know that developers are already familiar with Git as a version control system. So with introducing the GitOps into the market, or we can say that day-to-day activities, this would be very much simple and familiar to them. Because if they are going with the GitOps, so there would be a smooth transition for them to, just like us, to use Git along with their version control systems. There would be no much change for them. The second we would have, that is enhanced collaboration. So how GitOps would help to enhance the collaboration in developers' life, we can say that GitOps enables the collaboration through Git-based workflows, which allow developers to review the changes or track the histories, or we can say that manage the pull request. As of now, we know that code reviews are built into the workflow of, we can say that whatever the changes which we are pushing to the Git, or we can say that source code repositories, all of these are collaborated and managed by the developers. The next we would have that is consistency and reliability. As we know that GitOps enables and ensure that system is always consistent because it uses Git as a source of truth. So whatever the changes we want our system to be adapted or adapted, we are making those changes in the Git as well. And the next we would have the version change. So whenever we are discussing about making any change to our system, or we can say that our application would look like, the changes we are committing, making into our Git or GitHub, we can say that. And as of now, we are using VCS or version control system. Developers are already using it. So all are these being already versions. And we can see the track histories as well. The next we would have that is continuous reconciliation. So this is one of the most important point we would have in GitOps. We can say that whatever the changes we want, or we want our application to be look like, we don't need to rely on any of the DevOps engineer or a platform engineer. What we have to do, we just need to push that particular changes to the infrastructure code repositories, or we can say that environment configuration. Automatically our system or our application would adapt those changes. And we can see that in our wherever our environment is. And the next one we would have that is declarative configuration. So what does it mean by declarative configuration? Here it is that as of now, GitOps is mainly work with Kubernetes approach. So whatever the state of our application or system we want to define, we need to declare them in the form of state files. Just like as we can say that if we talk about the Kubernetes approach, so we need to define in the form of YAML. So this is how the declarative configuration would look like in the terms of GitOps. The next, we would discuss the CI/CD with GitOps approach. Before I discuss this, I wanted to, before I discuss this, I just wanted to share, before I discuss this, I just wanted to share a story which I have got a problem along with my developers. So developers came to me along with an issue that whatever the commit they just wanted to make into their code, it has been pushing to the artifact repository. But for an example, if they just wanted to make the application instances to increase from 2 to 5, for those changes also, it is going to change in their application code versions. So ideally, this is not correct because there is no change in the application code. So application version should not change. To solve those problems, GitOps would come into the picture, and that is very much helpful. Whenever we are, for an example, as you can see here, developer made a changes and pushes that particular changes to the GitHub. Automatically, it's the same pipeline or workflow, which I have shown in the first one, that is traditional workflow. The build has been triggered, and the Jenkins would wrap that particular artifact from the container and pushes that particular container into the Docker container registries. And automatically it would pull and deploy into any respective Kubernetes environment. Either it would be on-premise or any cloud, either Azure cloud or GCP cloud or AWS. So this is how the traditional way of CI/CD. But here, as you can see here, the blue one, that is GitOps tool, what it does. So as I said, GitOps continuously monitor Git as a source of truth. Whatever the information we have updated, either in the application code repository or the infrastructure code repository, the changes would be automatically sync and update to our Kubernetes environment, or we can say that on an application. So now with this approach, just suppose for an example, if a developer want to change any configuration, if they just wanted to test it, they don't need to rely on any DevOps engineer or any platform engineer to do and test that particular change. They just need to push that particular change into the application code repository or an infrastructure code repository. It would automatically sync and update to the respective environment. So this is how the CI/CD with the GitOps approach would look like. So there is one more scenario. Suppose for an example, in day-to-day activities, we have come across a situation that for just like as for approving some PRs or deploying into production, we need to rely on someone who has that kind of access. Whenever we are working with any cloud provider, we are already aware that there would be certain roles has been defined. So for having that particular certain rules, we need to wait for that guy that, okay, that guy came and they approve it, then only it will push to that particular change into the production. But with the help of GitOps approach, we can just like is eliminate those things. Along with that, whenever we are saying eliminating, it means that it has that feasibility to reduce that risk as well. Here, we can define the pre-checks and post-checks as well before we apply the directly changes to our application code. Suppose for an example, if we make any changes and we were not sure that, okay, this how it would be impact our running application code, we can define those checks in pre-checks and post-check in our GitOps tool. So automatically it is being managed by GitOps operator. The next we would have that why we were discussing what is the need of GitOps. So the first thing is that repository as the only source of truth. So as of now, for every information or every tools, whatever we want to implement in software development lifecycle, we need to go here and there just like us, ask someone who are senior, who had already worked on it, or over the conference to know the exact details, what we want. But with the help of GitOps, we just need to rely on the repository. And one of the most important thing here is that why I'm referring as a repository, I didn't mention Git or GitHub because whatever the GitOps tool which we are discussing here, they have integrated with GitHub, Bitbucket, GitLab, Azure DevOps, and many more. So there is no restriction that it can only interact with GitHub. That's why repository as the only source of truth. The next we would have that is declarative approach instead of imperative. So here it means that in declarative approach, we just need to only focus on the effect rather than go on the individual effect that led us to that particular effect. So we don't need to worry about any imperative command. Suppose for an example, if we have to make any change in the configuration of application, we don't need to run any or learn any command line utility for that particular clusters. We just need to declare that particular steps or state, we can say that in our information or infrastructure code repository, automatically it would apply to the respective clusters. The next we would have that is more automatic, faster deployment. As we have seen that for every code changes, there would be a CI/CD pipeline. But for every infrastructure changes, there is no CI/CD pipeline would required. Automatically, it is being handled and managed by the GitOps tool. So with this approach, there would be a more automatic, or we can say that faster deployment we would have. The next we would have that is self-healing mechanism. This is one of the critical one. Whenever we introduced a new tool into our SDLC, we are much more careful about that, how it would affect our existing application code. Suppose for an example, if our application, or we can say that with a pod, in the terms of pod or container, which is running fine in any one of the clusters, and if we introduced any change, what would happen? How it would try to heal? So in GitOps, there is an option, it would safely roll back to the previous version. We don't require to do any manual intervention or human intervention required to roll back to the previous version. The next we would have that is immutable and reproducible deployments. So what does it mean by here? So for every changes, suppose for an example, if there would be any break changes happen in my configuration which I updated in the infrastructure code repository. So what GitOps would do, it will not try to fix that particular change. It will replace the original one, we can say that the previous one that is very much stable and working fine. The next we would have the less human intervention. As I said, this is a completely automation process, so it doesn't require more human intervention to achieve the exact state, or we can say that the declared state. So here we will discuss the limitation of GitOps. In the limitation of GitOps, as we are completely rely on Git, or we can say that the version control system or any kind of code repository, so there would be a no secret management. Still, with the GitOps approach, we need to rely on external secret management, either would be HashiCorp, Vault, or Consul, or any other tools. The second we would have that with large projects, Git repo can be very complicated. Yes, indeed, just like as whenever the Git repo counts are increasing with the help of GitOps, that could be very complicated to manage them. In distributed projects, it would be very hard to manage them easily. The next we would have that is Git conflict with concurrent commit by GitOps. So as I said that, GitOps operator will also try to sync the changes which we did manually on the Kubernetes cluster. So there would be possibly that conflict can occur with concurrent commits by the GitOps. The next we would have that too many Git repositories. As we are completely rely on Git repositories, or we can say that source code repository, there would be too many for them to manage. So this is also comes under the limitation of GitOps. Due to the multiple commits, we would have the audit problems as well, because for same kind of thing, suppose for an example, if I'm the one who is making the changes into a respective code, and if someone is also make the change directly on the cluster, so the one changes which I did and the someone make the changes on the cluster, for the cluster is being managed by the GitOps tool. So there would be possible that there would be multiple commits. So for track those histories and the changes, there could be an possible an audit problem can happen. Now let's discuss what are the use case for the GitOps. So here is that GitOps for developers. Yes, indeed, this is being very much beneficial for the developers. If they just wanted to manage along with their application code repository, they can manage the infrastructure code repositories as well. So GitOps for platform engineer. So this tool is also can be integrated with, we can say that Terraform. So this is also being very much useful, or they have already using it, GitOps for managing their infrastructure as a code. GitOps for Kubernetes approach. As I said that GitOps is mainly worked on, we can say that integrated with Kubernetes approach. So that's why Kubernetes approach is very much, suppose for an example, if someone is working as a Kubernetes administrator, so GitOps for Kubernetes is very much useful for them. Now let's discuss the companies who has already adapted the GitOps approach. So there are more than 250 plus companies, they have already adapted the GitOps approach. So the information which I'm currently showing, this is being already published by Argo CD project, and these are available in their GitHub repository link as well. So the major one, that is Adobe, Volvo, Bosch, and many more. So if you want to go and check out the list that who are those companies which has already adapted this approach, so we can go and check it out, this link as well. So now let's discuss the GitOps supported deployment strategies. The first one we would have, that is push-based deployment. So whatever the changes which we are discussing here, suppose for an example, if developers made any changes and it made the changes into the application repository, it's the same kind of CI/CD pipeline which we discussed in our first slide, the traditional way of deployment. Automatically it would trigger the build pipeline, and it pushes the container image to the image registry. It could be any artifact registries, and it would update the environment repository as well. And automatically it's trigger the deployment pipeline, and it would deploy into the respective environment. It could be either AWS, GCP, or any on-premise environment. Now let's discuss the GitOps supported deployment strategy, that is pull-based deployment as well. So here, as we can see, this is the important one. As we can see, the GitOps operator is sitting in our Kubernetes environment. And what it does, it is continuously monitoring the image repository and the environment repository. Suppose for an example, if developer made any changes in the code repository, it will monitor that change as well. And if the same developer or someone who is working on the same project or same code, if they made any changes to the environment repository, it observed that repository as well. And it will sync to our respective environment. Either it would be any Kubernetes or any other environments. And this would be vice versa as well. For an example, if I'm being as a DevOps engineer, if I made any changes to my pod or deployment, so automatically what it does, it will write that particular changes to the environment repository as well. So it would be aware that what are the changes has been proposed to my application. Now let's discuss the first one and the most important tool, that is Flux CD. So, and the importance of Flux CD, I'm discussing here that it can be vertically scalable, and we can monitor hundreds of clusters with the help of Flux CD. So this has been already developed and managed by CNCF. Linux Foundation is currently managing it. So the most popular GitOps tools for Kubernetes is Flux CD. So Flux, what it does, it continuously tries to synchronize the repositories to our running resources in Kubernetes clusters. So whenever there would be changes in our repositories, automatically it would try to synchronize the running resources in the Kubernetes. So for what we requirement for this to deploy this Flux CD in our Kubernetes cluster. The first thing we require the running clusters, a Kubernetes cluster that should be in running state. And the second one, we required a token for our GitHub repository to have an access. And the last one, we required the user. So as you can see here, for bootstrap this Flux CD, we pass the same thing, Flux bootstrap, GitHub, and we pass the user and the repository, and we pass the branch information, and the same one for the path. And the right-hand side, I have shared you the snap as well. What are the components which I have mentioned, that like got component, got sync, and customization. If you're not aware of the customization is something that inbuilt for Kubernetes. Inbuilt, we can say that tool just like as we have it for kubectl command line utilities. But that is with the help of customization, or we can say that advancement or enhancement, what customization provides us that, it helps us to manage or modify the application code repositories without changing the original one. Suppose for an example, if you have a multiple environments, and if you managing this multiple environment in multiple YAMLs for their infrastructure code, and if you have to make any changes, suppose for an example, for development, you want to make your application code or application instances to 2. For pre-prod or UAT, you want that those instances to 5 or 8 or 10. So you can do that with the help of customization, just like as it will try to manage it in the form of patches. So this feature is being already available in Kubernetes. And now let's proceed to the next one, that is Viv GitOps. In Flux CD is completely CLI based. So Viv GitOps provides UI based features. So as you can see here, I have already pasted this information that what kind of dashboard YAML it is. So this is being kind as Helm repository, and this is how the Viv GitOps UI would look like. Here in the application, the first one is Flux CD. The kind for that particular Flux CD or Flux system, we can say that is customization, and that has been deployed in Flux system namespace. And the source for that particular namespace is Flux system, and the status for them is ready. I have deployed only Flux system in my Kubernetes clusters, but the GitOps, or we can say that the GitOps UI is being already deployed and managed by Flux system. So we don't need to deploy it manually. We don't need to run any command for that. Whenever we placed that particular YAML into respective repository, automatically it would apply to our respective clusters. This is how the Kubernetes cluster with Flux CD would look like, the demo which we have prepared in this conference. This is the workflow. So we make the changes. Whenever we make the changes and pushes the changes to the GitHub source code repository, it would trigger, build would trigger, and we have used GitHub Actions for that. And we used GitHub container registries for storing those artifacts. And automatically we have the changes, or we can say that the container or the images would be automatically pulled by our Flux. So here we have created a cluster, Kubernetes cluster on AWS EKS, and Flux is sitting in that particular clusters. So now let's proceed and see the next one. Sorry. Stop moving. Trying. Okay, sorry. So as you can see here, this is the work folder structures which we have prepared for this. The first one is the deploy that we have maintained here at deployment.yaml, customization.yaml, and the service. We have created a sample service. Along with that, we have exposed that. We haven't exposed that particular service outside of the clusters. and to sync the image automation. So whatever the changes which we are proposing to our application code, and it would automatically reflect those changes, and our application would run the same as expected. We have created an image policy as well. For applying the image policy, we have to mention the image repository, which you can see here, the image repository.yaml. For this, as you can see here, let's go to the next one. This is the snap which shows the image policy which we have defined. So this is the snap from our deployment.yaml. So this is our image, and this is the tag 1.0.0, and this is the image policy. For an example, if there would be any change in our versions of our application, automatically it would get reflected in our GitHub container registries as well, and in our application code repositories as well. So this is how the Flux CD deployment would look like. So whenever we update or mention our application code into our source code repository, automatically it is being tackled and managed by Flux CD, and it's get deployed into our respective Kubernetes clusters. So as of now, you can see here the web app is being deployed, and the kind is showing is the customizations, because we have used this customization to deploy it, and the name of the application is showing as web app. And in the above, the snap shows the same thing. For Flux CD, what we have used, the URL which we have passed. And this shows the snap whenever we try to see what's mentioned over there in that particular application. As you can see here, there's an option for sync. So we can define it that how often we want to sync our existing Kubernetes clusters or applications to try to sync to the same source code repositories. And here the image versions is already showing 1.0.0. Whenever there would be any change in our application code, automatically it would get sync and version would get bumped. So as we can see here, I have been make the changes to 1.0.0 to 1.0.1, and automatically the same changes has been pushed and committed by the Flux as well into our GitHub. We'll show this all information in the demo as well, then how it is happening. As I said that in GitOps, Flux CD and Argo CD both follows the pull-based deployment strategies. So the GitOps agent, which is sitting in our Kubernetes cluster or AWS EKS cluster, it's continuously monitoring whatever the changes is being done on cluster level, or we can say that in our environment configuration, they both are try to be in sync. So the image has been changed, so automatically our environment configuration has been already upgraded from 1.0 to 1.0.1. So the same we can say that, as I said, the continuous reconciliation is one of the key for this GitOps tool. So this reconciliation is finished in 182 milliseconds. This is not in, we can say that fraction of second that has been already done. So this versions upgrade that has been done in 182 milliseconds. And one of the most important thing here is that we can define the sync policies as well. Suppose for an example, for production or for any other environment, we don't want this automation. We don't want this continuous sync very often. We can set it up to the manual as well. Now, let's discuss the next. We have this GitOps tool that is Argo CD. In the workflow diagram, as you can see here on the right-hand side, it shows just like as in Flux, we don't have this UI capability. We need to rely on Weave GitOps. Weave GitOps has public, or we can say that the free version, and they have the enterprise versions as well. But in Argo CD, we don't need to rely on any other tool. It has UI capability, it has CLI capability, and it has the gRPC REST API capabilities as well. So whatever the information we just wanted to share here is that it will integrate with any of the kind of repository. Either it would be GitHub, GitLab, Bitbucket, or Azure DevOps, or any just like a cloud repository which is residing in any one of the cloud. The first, we would have that it has the ability to manage and deploy to the multiple clusters. So whenever we are discussing about the scaling part, we need to understand that whatever the tool we are introducing to our software development lifecycle, we need to understand that how it would be scalable. Does it going to be work for only a single cluster, or we can use it for the multiple cluster? With the help of GitOps approach, we can use this to manage and deploy to the multiple clusters. And whenever we introduce a new tool, we need to understand that what kind of authentication we are going to pass it on. So this Argo CD has this SSO integration. We can use either OIDC, OAuth2, LDAP, SML, GitHub, GitLab, or Microsoft. Any kind of authentication we can integrate. In the last slide, we have shown we are passing the credentials for the Weave GitOps UI. But in the Argo CD, for the UI-based feature, we can integrate any kind of authentication here. So multi-tenancy and RBAC policies for authorization. So whenever we are discussing here, just like as the container, or we can say that the cluster which is running on multi-tenancy, we can define, because the GitOps is mainly working with Kubernetes approach, so we can define the role-based access policies as well for authorization. We can create roles, we can define just like as cluster-based roles or namespace-based roles, and accordingly we can use that. The next we would have, that is rollback or roll anywhere to any application configuration committed in Git repository. So with the help of GitOps approach, we don't need to rely on someone to do the rollback. Automatically the previous version or the stable one, it would do the roll. Suppose for an example, if we made the changes to 1.0.1 and 1.0.0 is the stable one. So automatically it will track the changes or track the history in the Git, and it will do the rollback. We don't need to rely on someone or trigger any pipeline to do this. The next we would have, that is automated configuration drift detection and visualization. As I said, Argo CD has this UI capability. So whatever the configuration or the operation is being performed by Argo CD, we can see this in the UI features, and this drift detection can be also visible in it. So the next we would have, that is automated or manual syncing of application to its desired state. So as I said in the first, that we have in place of automated syncing, we have an option for the manual sync as well. If we don't want our application to be automatically sync to the desired state, we can make it pause, and we can do this manual syncing of our applications as well for the desired state. Now let me try to show you some demo. As you can see here, this is our application web app, and this is currently running in 1.0.0. So I just went through this repository. I make the version change from 1.0.0 to 1.0.1. I'm just pushing that particular change into my GitHub source code repository. So the changes has been already pushed. And now my GitHub action would work, and it will try to make an artifact and push that particular changes to the GitHub container registry. So GitHub action has been worked. Now our GitHub container registries has been already upgraded from 1.0.0 to 1.0.1. In image automation, with the help of image policy, we can see that currently the tag count is 1. We just need to do this manual sync. We can make this automated as well, and the tag count has been increased from 1 to 2. And the image update automation, you can see that in the events it will show that it has already pushed that particular change to the GitHub. When you just refresh it, it will show it here. Yes, as you can see here, this automated manage update by the Flux. So Flux did this manually update this version upgrade from 1.0.0 to 1.0.1. And in the same, we can see in our application code as well, this upgrade has been already done. So our application is already upgraded from 1.0.0 to 1.0.1. So this complete reconciliations happens in 5.2 seconds. So we can, as you can see here, in the next run is showing us in 30 minutes. So we can do this all setup that when we want our next process to be run. So now let's discuss what are the key takeaway from this topic or conference. that the first we would have that is automation of infrastructure management. As of now, we can say that the infrastructure management is, as of now, we need to rely on some tools, just like as if we have to do this infrastructure management, we need to rely on HashiCorp tools, just like as Terraform. But with the help of GitOps approach, we can just like as eliminate that. The second we would have that is declarative state control. So with the help of declarative state control, whatever the state of our application we want to declare, we can maintain that particular in application code repository or infrastructure code repository. Automatically, it will apply to our respective clusters. The next we would have that is fast and safe rollbacks. So whatever the version, or we can say that rollback to the previous one, we can do that with the help of GitOps. That would be very fast and the easiest one, we can say. The next we would have that is continuous integration and the continuous deployment. So here, just like as we have to understand the GitOps approach, we are not changing the existing CI/CD workflow. We are just introducing a new tools that will help to enhance our existing CI/CD workflows. So now, do we have any questions or anything to ask here on related to GitOps? Thank you for joining us today. Follow us for more insights on GitOps related things. So this is me, and this is my colleague Yaroslav Zerwinski. He's an AWS community builder as well. He has this blog, www.reddevops.pl, where he continuously shares insights on different DevOps related tools and technologies. Along with my professional journey, I'm sharing insights and information related to DevOps tools on YouTube as well. And my channel is TechWise Rahul. And along with YouTube, I'm sharing my experience on Udemy as well as an instructor. Thank you.